This is the second half of the polycarbonate lecture for thermoplastic resins, and we're going to talk about major application areas for polycarbonate. A lot of polycarbonate is used in optical media and CDs or DVDs. They're kind of losing that sort of market share, but it is still used extensively. It's also used for glazing applications and sheet material. Glazing meaning replacement of window glass. It's used in electrical and electronics, transportation, automotive, medical, computers, appliances, recreation, packaging, and then the ubiquitous other category. Here are some of the major applications. A lot of sheet material, some film material, automotive, bullet-resistant glass being the big one, and I always use the term bullet-resistant when I'm talking about Kevlar or polycarbonate because it really only refers to certain calibers and certain distances. So many things that have been are kind of thrown around as the word bulletproof are not truly bulletproof. So please, I don't want to hear about you going out and testing exactly how much caliber a piece of polycarbonate can withstand. In fact, I'm telling you to not do that. That's a really bad idea. But the thing is, polycarbonate has really good impact resistance, and that's what's good for bullet-resistant reactions and also safety glasses. Your lenses on your safety glasses are polycarbonate, and they can withstand an impact. They can be penetrated to some degree, and it won't get to your eyeball, which is really super important for safety glasses. And they have to have a certain ASTM rating to be considered appropriate for safety glass lenses. Also, a lot of electrical applications and things like that. When you're talking about CDs and DVDs, a typical CD consists of a polycarbonate substrate. And what the polycarbonate substrate does is it acts as a lens that focuses the laser beam. And it's a laser that actually reads the media that's in here. So you have your polycarbonate substrate, it focuses that laser beam onto the metallic film that contains the information that produces the sound or the picture or both. Within that metallic film consists of gold or silver alloy or aluminum, and that's where your data storage actually occurs. PMMA is used on top of that to produce a weather-resistant and anti-UV light film, because polycarbonate does not do well with weather or UV, and so it needs the PMMA film on top to protect it from that. And then, of course, there's a decorative label usually on top. Polycarbonate is also used widely as windshields for military vehicles because they have good impact resistance. Snowmobiles, motorcycles, also used for laminated security panels. Laminated security panels being the things in place of, say, glass for a secure application. For electrical and electronics, polycarbonate is used in places that have very demanding requirements. So something that requires ductility, flammability resistance, toughness in thin sections, high service temperature, fast production cycles, a spike in temperature resistance, and miniaturization. Polycarbonate can meet all of these demands. So when you're looking at that, things like connectors, battery casings, electrical chargers, distribution housings and covers, mobile phones, calculators, switch plates, enclosures for fluorescent lamps, high molecular weight polycarbonate for capacitors, and EMI or ESD shielding. Well, what's EMI? EMI is electromagnetic interference. And so shielding is something that prevents electrical discharge, and that is something that can cause a major cause of undesirable side effects in electronic devices and components. So use EMI shielding to be able to use multiple devices without them interfering with each other. And this is an application area where they use a stainless steel filled conductive resin, and it's both cost effective and environmentally friendly. This replaces traditional metal plating, and it's better than conductive painting or metallizing of other things. And because the stainless steel is integrated into the resin itself, you can get much better shapes and things like that in the parts that you're using. Here's a portable DVD player and a projector. Now, many people may not use DVDs or portable DVD players. I do because I have a small child who I have to drive across the country with, so that really comes in handy still. They're used extensively in automotive and transportation applications, dashboards, lighting, especially the lenses on fog lights or headlights. They have to be clear, but they have to withstand impact of, say, really big bugs or rocks coming up from the road. They're used in interior trim and instrument panels, door handles, body panels, radiator grills. Radiators get a lot of impact, and so the polycarbonate is good for that. hubcaps, and spoilers. They're also used for street light globes, so they need to be clear, but they need to withstand, say, people throwing rocks at street lights. They're also used for airport strip light covers that are at ground level, and they're used for bus shelters. So that's your protective glazing application. Instead of glass, they use polycarbonate for bus shelters. So here's an example of lighting applications. Sabix Lexan is used in the Ford Taurus headlamp, and Macrolon is used in the LED 2000 series of UV light stabilized lenses. Sabic also uses a Lexan LED in the Ford Mustang. There are a lot of medical applications, and the reason why polycarbonate is used extensively in medical applications is because it is physiologically inert. It's sterilizable for anything that needs to be reused. So it's something that's not single use, like a syringe or something. If you need to sterilize that, it needs to withstand those conditions, and PC can withstand that. It's clear. It's really useful to see what's in the material you're using, and it has exceptional mechanical properties. This is often used in dialysis equipment, surgical optical piping. A lot of times you're not actually opening someone all the way up, you're using fiber optics, cameras, and things like that laparoscopically, so that's where they'd be used. Same thing with surgical retractors, handles, and staples. They're not used in too many syringes. Many syringes are one use and throwawayable, but polycarbonate can be used in syringes, tubing connectors, catheter connectors, and drug delivery devices of the reusable kind, the kind that needs to be sterilized. We often see polycarbonate in unbreakable bottles. That is, we are moving away from that because of the concerns about bisphenol A. Also, household electrical appliances, that's still widely used. Again, if you drop something, you don't want it to shatter, and polycarbonate can prevent that. Kitchenware is often used in coffee machine housings and on vacuum cleaners. Because you can also color polycarbonate very easily. I don't know about you, but I run my vacuum cleaner into various pieces of furniture and walls and baseboards and whatnot all the time. It's a plus to not have that shatter when you run your vacuum cleaner into it. There are concerns of bisphenol A, and the two main polymer products that use that are polycarbonate and also epoxy resins. And so when polycarbonate and epoxy resins come into food or medical contact, there is an ethical concern about the usage of bisphenol A as a raw material for these plastic materials. You often see, especially on baby bottles, things like, oh, bisphenol A free, and that is a concern. And so what are the concerns? Well, there's something called environmental estrogen, and that can come from a couple different sources: phytoestrogens and man-made chemicals. Phytoestrogens are plant-based estrogens found in plants, and soybeans is one of these, some other grains. And so these are estrogen-like molecules that are found in things. And also man-made chemicals can be environmental estrogen. Certain chemicals have estrogenic properties. So what is the problem? Well, naturally, people produce estrogen. Men and women both produce estrogen, women more so than men. But your body naturally produces it at a certain level. Now, if everything's running properly, you don't need additional estrogen. But if you start having some of this environmental estrogen, it can act as an endocrine disruptor. So it acts as an exogenous substance that alters the function of your natural endocrine system that produces your natural hormones. So it messes everything up. And what this can do is it can cause adverse health effects, obviously. If your hormones get all messed up, if you're a male, say, and you have all this extra estrogen, that's not necessarily good. Or if you're female and you have estrogen coming in when it should not be, it can cause problems. Not only to the intact organism, the person who ate the environmental estrogen, but also offspring, or the offspring of offspring. So it can cause genetic issues as well. So environmental estrogen is no good for the endocrine system. And here's where BPA comes in. BPA is an estrogen mimic, and it can bind to estrogen receptors. Now, women have more estrogen receptors than men, but both women and men have estrogen receptors. And what it does is it alters your endogenous hormone synthesis. In other words, your body produces a certain amount of hormones like it should. When you bring something in from the outside that binds to an estrogen receptor, it kind of throws a monkey wrench in the works. It messes up your hormone metabolism, it messes up your hormone concentrations in the blood. And so if you're exposed to BPA, it can cause changes in your tissue enzymes, it can cause changes in your hormone receptors, and then that interacts with all other systems that behave based on that hormonal response. So this all sounds really bad, like it's just a whole cascade effect. All these dominoes are falling. It's awful, terrible. Well, hold up, don't panic just yet. This is why this is estrogen shown here. This is bisphenol A. Now your estrogen receptors actually bind this area of the molecule, and you can see here that bisphenol A has a similar area of the molecule. Not only does it have this similar area, it has another one on the other side. So it can actually bind estrogen receptors a little bit better if it's present in your body. Now it's if it's present in your body. That's the big question. The mimicking effects of BPA are bad for you, but there are people who do not understand exactly what the process is, and have you believe that BPA is present in anything plastic. That is just not true. It is only present in plastics in which it is used for synthesis. And the problem is that certain TV personalities, like Dr. Oz, have talked about BPA being everywhere and ubiquitous. And it is true that a lot of these chemicals, industrial chemicals, are not present in standard drinking water testing, like BPA, like some other residual chemicals from steroid-type drugs or things like that. Now, if that is the case, you can have these external estrogens that can mess stuff up. But the concentrations that are present in the drinking water are not terribly concerning. Now, you can use other alternatives to polycarbonate for food containers, and shockingly, they are cheaper than polycarbonate, like polyethylene or polypropylene. But these don't have the same properties in terms of clarity or in terms of impact resistance. Now, they have done environmental studies, honest-to-goodness studies that don't come on early afternoon television. And what they found is that BPA leaching from a polycarbonate container is very, very marginal. That is 4.7 parts per billion, or 0.00000047% of the content. Now, the U.S. Federal Food and Drug Administration considers polycarbonate containers to be acceptable. Now, for something to be a problem, the Environmental Protection Agency has stated that BPA consumption should be 50 micrograms per kilogram weight per day. And there's no way that this 4.7 parts per billion, even in a little bit degraded polycarbonate container, reaches this 50 micrograms per kilogram. Now, it is important to not consume BPA. And consuming monomer is generally bad for you. And smaller people are more susceptible to the risk of polycarbonate food containers, so it should be eliminated in food containers for children and babies. But largely, for a healthy adult, BPA is negligible, not much of a risk. So this is an instance in which marketing has kind of misled people as to the danger of plastics in the environment. So this concludes the polycarbonates lecture. From here, we are going to pick up with polyacetal.